Hello everyone, welcome back to our data structures and algorithm series. So the question which we'll be solving today is rotate array. So in this question, we have been given an array and we have to rotate the array by k number of times. For example, in this case, we have given 1, 2, 3, 4, 5, 6, 7 and we have to rotate it by 3 units. So what I'll do, this 1 will rotate by 3 times. So 1, 2, 3. So 1 will be here, 2 will be here, 3 will be here, 4 will be here, right? And this 5 is rotated by 3 times. So 1, 2 and 3. So 5 will come at the start. Now 6 will come at 1, 2, 3. So 6 is here. And 7 will be 1, 2 and 3. So 7 will be here, right? So we have to right shift the given array by k number of times, right? That's the question. So let's see how we'll solve this. First, take this example. 1, 2, 3, 4. Let's take a small example first, right? Now imagine I have to rotate this array by 0 units. Imagine, like, so what will be the answer will be 1, 2, 3, 4, right? Because 0 units. If I have to rotate it by 1 units, what will be the answer? It will be 4, 1, 2, 3, right? Because 2 will be here, 3 will go at one place, 4 will come at the start and 1 will go at it, right? Now if I rotate by 2, it will again be like 4, 1, 2 and 3 will be at the start, right? If I rotate it by 3, again 3, 4, 1 and 2 will be at the start. If I rotate it by 4, again 1 will be at the start and 2, 3, 4. We got the same array if you rotate it by 4 times. So what's the first observation from this question you have? 1, 2, 3, 4. If you rotate by 4 times, if you rotate by 0 times, if you rotate by 4 times, if you rotate by 8 times, if you rotate by 12 times, you'll end up at the same array. Why? Because number of elements are 4. If you rotate by 4 times, you'll end up at the same. So if you rotate by any multiple of 4, you will end up at the same array, right? Now if you rotate by 5 times, right, what does this mean? Now, while rotating by 4 times, I'm ending at the same array. So rotating by 5 times is same as rotating by 1 time, right? Because if you rotate at 4 times, you'll end up at same array. And now you have to rotate by 5 times. So rotating by 5 times is same as rotating by 4 times. So can I say my only possible answers are like 4? Either I can rotate it 1 time, 2 time, 3 time, or 4 time, right? Because in 1 time I'll get some answer. In second, if it rotated by 2 time, I'll get some answer. If I rotate it by 3 time, I'll get some answer. If I rotate it by 4 time, I'll get the same answer. Now if I rotate it by 5, it is same as rotating it by 1 time, because at the fourth you are getting the same. If I rotate it by 6, it is same as rotating by 7 times. If I rotate it by 7, it is same as by 3. If I rotate it by 8, it's same as 4. Again, if I rotate it by 9 times, it is same as rotating it by 1 time. If I rotate it by 10 times. So the very first thing is, what I'll do, I'll just do k equal to k mod n. Why I'm doing this? Let's say k was 5. So 5 equal to 5 mod of 4. This will give you 1, which means just rotate by 1 time. No need to rotate by 5 times, because rotating 5 times is same as rotating 1 time. So if k is 1, let's say, so 1 mod 4 will be 1, right? K is 2. So 2 mod 4 will be 2. K is 3. 3 mod 4 will be 3. And k is 4. So 4 mod 4 will be 0. And that's what we just saw. Rotating by 4 times is same as rotating by 0 times. So the very first thing is we'll just bring our k in the range of 0 to n. That's our first thing. And how will we do that? K equal to k mod n, right? Rotating an element k times is same as rotating it by k mod n times, right? So this is our first step. We first brought it in our range, like 0 to n, right? Now look at our example. 1, 2, 3, 4, 5, 6, 7 and k is 3. 1, 2, 3, 4, 5, 6, 7 and k is 3. After rotating, your array will become like this, right? Like these 3 elements will come at the start and these 3 elements will go at the last, right? So what's the first thing? The one thing which you can do is you can simply make an extra vector, like, fine. Now you have to rotate it by 3 times. So start from this index. You have to rotate it by 3 times. So these 3 elements will go later, right? So what I'll do, I'll just push these 3 elements here in the last, right? You start your iteration from here and you can easily get this index, right, by n minus 3, which is in this case 7 minus 3, 4. So this is the fourth index, right? So start your iteration from here, which is 5, 6 and put it in your new array. Then again start from iteration from start and put it in a new array, 1, 2, 3, 4. So you can easily solve this if you can use an extra array. Like, let's understand this again. 1, 2, 3, 4, 5, 6 and 7. You have made an extra array which also consists of 7 elements, right? So start your iteration from n minus k. K is in this case 3, right? N is 7. So 7 minus k is 4. So start your iteration from fourth, put it at the start, like this, this and this. Then start your iteration again from here and put it after this, 1, 2, 3, 4. You got your answer. This is your answer, right? So if you use an extra array, the question is simple. Like, you can solve it in big O of n time complexity and big O of n space complexity, but we have to do it in place. We can't use an extra array. So our expected space complexity is big O of 1 and time complexity is big O of n. So how will you do it in place, right? So let's look at the example again. 1 2 3 4 5 6 7. So 5 6 7 and 1 2 3 4, this is your final answer. What one thing you can observe from this is, these three elements you have to rotate by 3. So these three elements come at the start and these three elements have went to the last, right? So your only task is move the last k elements to the start and the remaining n minus k elements to the the remaining last k elements to the first, and the first n minus, these are k elements, right? K is 3 in this case and these are n minus k elements. So move the last k elements to the start and move the first n minus k elements at the bottom. That's your only task. Simple, right? So how will you do this? Now it's pretty simple, right? What you'll do, you just reverse these elements, right? If you reverse these first four elements, what you will get? 4 3 2 and 1. Now reverse these elements remaining, which is 7 6 and 5, right? Now reverse the entire array. What will reverse? The entire array I'm saying, which is 5 6 7 and 1 2 3 4. Just reverse the entire array and you got an answer, right? So this is will reverse like the, and this is very useful in a lot of question, not this question. If you want to reverse like array from between, then this is how you do it, right? If you want to shift the array, this is how you do it. So that's how we'll solve the question. So the first step is find n, which is nums dot size, then k equal to k mod n. Why k mod n? That's I made you understand, because if k is greater than like n, then there is no use of doing it again and again. So first bring it in a range of 0 to n. So now k is in a range of 0 to n. Now what I did, first I reverse nums dot begin to n minus k, like this reverse function, nums dot begin and nums dot begin plus n minus k. So this reverses the first n minus k elements. What does this do? This reverses the n minus k elements. This will reverse nums dot begin plus n minus k to nums dot end. So this will reverse the last k elements, like this will reverse the last k elements, and then we have reversed the entire array again, right? So that's what I did here, right? I first reversed this first four elements, 4 3 2 1. Then I reversed these three elements, which is 7 6 5. Then I reversed the entire array, and that's how we got your answer. That's it. We didn't have to, and once you reverse this entirely, you will get this array, and you have to just do this. That's it. So that's how you'll solve this question. If you run this, you will see it runs fine. And if I submit this, you can see it runs like pretty smoothly. So yeah, so that's it. That's how you solve this question rotate array. So if you like the video, please do subscribe to our channel, and I'll meet you in the next one. Thank you.